have been working with is right triangle trigonometry. So everything that we've learned, all those definitions of sine, cosine, tangent, secant, cosecant, cotangent, all of those only work with right triangles. Pythagorean theorem, a squared plus b squared equals c squared, only works with a right triangle. So we still want to do trigonometry study of triangles, right? We still want to do trigonometry, but these are not right triangles. These are oblique triangles. And so when I use the law of sines, I'm going to use it to solve oblique triangles, and those are just triangles that are not right. I'm actually going to use two different things, law of sines and law of cosines, to solve my oblique triangles. So the first one of those, law of sines, is what I'll use to solve an angle-angle side, an angle-side angle, or a side-side angle. Now, what do we mean by those? So let's go back and review a little bit from geometry. An angle-angle side triangle is like this first figure that we have here in example 1. It's when I know two of my angles and one of my sides, but it's not the side that is in between those two angles. So an angle-angle side is when I know two of the angles and one of the sides, but it's not the side in between the two angles. Angle-side angle is when I would know two of the angles and one of the sides, and it would be the side in between those two. So if I had known side A instead of side B here, that would have been an angle-side angle triangle. And then the last one, a side-side angle triangle, is like the one you see down here in example 3. That's when I know two of my sides and one of my angles, and again, it is not the angle between those two sides. That's called a side angle side triangle when I know the angle between the two sides. So side-side angle is when I know the two sides and an angle, but it's not the angle in between the two triangles, angle between the two sides. So those are the three types of triangles I'm going to be able to use law of sines for. So here's what the law of sines says. The sine of angle A is to little a as the sine of angle B is to little b as the sine of angle C is to little c. What we're going to do is we're going to set up a proportion. In that proportion, we're just going to set two fractions equal to each other. So we're not going to use all three parts of this proportion at the same time. What we'll do is we'll set sine A is to A as sine B is to B equal to each other. Or we'll say sine B is to B as sine C is to C and set these two parts equal to each other. Or we could even put the A's with the C's. There are also several ways that I can write this formula. Like you'll notice in the textbook there on page 428, they write it in an inverted form to what we have it. Like they write little a is to sine A as little b is to sine B as little c is to sine C. If you think about it, if you flipped all three of those, they would still maintain that same proportion. So we could do that. So multiple ways of writing this and using it. When we're working with our triangles, we saw this before when we had to solve a triangle, but when we write out our triangle, there's something that's extremely important. I have to make sure that I put the angle and the side opposite that angle. I have to make sure they have the same letters. So if this is angle A, then straight opposite of it, I have to have little a. If I don't label them that way, then I'm not going to come up with the right answers. And then also remember they used capital letters for the angles and they used lowercase letters for the sides. All right, so for the first example, it says for the triangle in figure 6.2, angle C is equal to 102.3, angle B is equal to 28.7, and side B is equal to 27.4 feet. Find the remaining angles and sides. So they also sometimes say solve the triangle, and that just means find the remaining angles and sides. All right, so let's start with angle A. How can I find angle A?
Subtract angle B and C from 180.
Okay, subtract angle B and C from 180. 180 degrees in the triangle, subtract the two angles that I already know, and that'll tell me the third angle. When we were doing this before, we were rounding our angles to the nearest tenths, and we were rounding our sides to the nearest hundredths. So let's just kind of keep going with that pattern so that we won't have any question of what to round to. All right, now I want to find little a. So out of the three parts of this proportion, I'm going to pick two parts. Obviously, I need to pick the a's because I'm trying to find a. So I'm going to have sine A is to A. I'm either going to set it equal to a pair of B's or a pair of C's. I don't really have a choice. Because if I set it equal to the pair of C's, if I say sine C is to C, I don't know little c, right? So I can't solve for little a and little c at the same time. So my only choice then is to set it equal to the B's because I know both of those. So that's how I can figure out which two pieces of the three parts of the proportion to use. All right, so let's plug in what we know. Angle A is 49, angle B is 28.7, and little b is 27.4. So how am I going to solve this proportion? Cross multiply, that's a good place to start. And then, yeah, divide both sides by the sine of 28.7. Degree mode or radian mode? Degree. And for your quiz tomorrow, you're going to be working on a scientific calculator. So I would encourage you, go ahead and grab your scientific calculator, and while we're going through class today, practice plugging these into your scientific and make sure that you're coming up with the right answer so you know the keystrokes to use. Now, when you go to put this in your scientific calculator, we've mentioned this before as well, be sure you don't round till you get to your final answer. Because, like, if you find the sine of 49 and you round that, and you find the sine of 28.7 and you round that, and then you take your rounded sine of 49 and multiply it by 27.4 and you round that, and then you divide it by this that's rounded, and you round that, by the time you get done, you're going to be off by a couple of tenths. So the nice thing is you can just leave the whole thing 8, 9 decimal places in your calculator and keep multiplying and dividing, and then just round your final answer. So everybody getting that to work okay? Anybody having trouble with it? Okay, so let's find little c. If I'm going to find little c, I can use Pythagorean theorem, right? Because I know a and b, so I can do Pythagorean theorem to find c, right? Yes, no. Why no? This is not a right triangle. That is going to be so hard for us to get used to, because for 2 months, every single problem we have done just about everyone. We've done Pythagorean theorem, right? We've definitely done it in every single section, every single day for the past 2 months. So it's going to be a big change for us. So we just want to be sure that we don't make that mistake. So that's why I was trying to stress that to you here, not really trying to entrap you, but trying to stress that to you. All right, so instead we'll go back to that law of sines. If I'm trying to find c, I of course have to use the pair of c's, right? And now I do know both of the a's and I do know both of the b's. Just my personal preference, I always go back to the given information, so that if I made a mistake in finding my A's, that it doesn't then cause me to get the wrong answer when I'm finding the C. So I'm going to go back and use the B's that were given. So we'll put in 102.3 for angle C, 28.7 for angle B, 27.4 for little b. All right, so how are we going to get C by itself? Cross multiply, and then divide. Yep, so exact same process we used a second ago. Throw that into our calculator. Don't round until we get to our final answer. One of the things that I love most about math is that it is very exact. It's black and white. There's exactly one right answer. It's either right or wrong. There's no ambiguity, right? Until we get to a side-side angle triangle. A side-side angle triangle is called the ambiguous case because you can get no solution, one solution, or you can legitimately get 2 different answers for the same angle in one triangle. That's just like crazy to me. So let's look at this one, all right? When you have a side-side angle triangle, flashing lights need to start going off. You got to watch out for this one. So, a side-side angle, remember, is when we know 2 sides and we know an angle, but it's not the angle that's in between them. That is the only time that I have to worry about the ambiguous case. So, I'm going to start solving this by trying to find, well, let's see, I have a pair of A's that I could use. And the only other piece of information that I have is a b. So I don't really have a choice. I'm going to have to start by using a's and b's because that's all that I have. So I had the pair of a's, I know one of the b's, and I'm looking for the other b. So let's plug in what we know. Angle A is 42, little a is 22, and little b is 12. Trying to find angle B. So how do I get sine B by itself? I could cross multiply, nothing wrong with that, but there is a little shorter way of doing it this time. Yeah, if I multiply both sides here by 12, I'll just eliminate one step for myself. Because if I cross multiply, then I'll still have to go back and divide by 22. If I just multiply both sides by 12, then I get the same answer, just save myself a step. So, anytime we can save ourselves a little bit of time, we'll do that. All right, so I'm going to throw this into my calculator in degree mode, and I get sine B is equal to 0.36. That does not mean that angle B is 4/10 of 1 degree. That means the sine of angle B is equal to that, not angle B. So these are like our Jeopardy questions again, right? When they give me the answer and we're looking for the question, how do I find that on my calculator? Second sign, right. So inverse sine, second sign is our Jeopardy button. So we'll type second sign or inverse sign of that decimal, and what it shoots out for us is our reference angle. Now, we've done this a couple of different times. When we worked with inverse trig functions, the one answer that the calculator gave me was my one answer. But every other time that we've worked with this, we've had to go back to that scenario of sine is positive in two different places, so I'm going to have to give the first quadrant answer and the second quadrant answer, right? So what my calculator gives me is my reference angle. So for the first quadrant, remember back in section 4.4, a reference angle is just the distance that you are away from the x-axis. So in the first quadrant, your reference angle and your first quadrant angle are the same thing. However, in the second quadrant, if I want to find this, I'm going to say, okay, reference angle is distance away from the x-axis. So if I start right here at my x-axis, which is 180, and I go the reference angle 21.41 away into the second quadrant, that's just going to be 180 minus 21.41. So that would give me 158.59. Both of those are potential answers for angle B. They could both be solutions for angle B. All right, so how am I supposed to know if one of them is the answer or both of them are what? Well, I have to go back to the triangle that they gave me. When I go back and I look at this triangle, I already have a 42-degree angle in this triangle. Can I have a 42-degree angle, a 21-degree angle, and room for a third angle? Yes, so that one's fine, right? Can I have a 42-degree angle, 158-degree angle, and room for a third one? No, I'm already over 180. That's not possible. So that's how I know that 158 is not a viable solution here, and the only one solution would be the 21.41. So that's what one solution looks like. We'll look at two solutions and no solution in just a minute, but that's what one solution would look like. There is only one possibility out of the two answers that I got that will work. Okay, so now we finished solving like normal. How do I find angle C if I know A and B? Yeah, just subtract from 180. So add them up and subtract from 180. And then I'll have angle C. And then I'm going to find little side C, right? So if I'm finding little side C, I definitely have to use the pair of C's. And I'm going to try and go back to the given information, and that was a pair of A's. So I'm going to use those two parts of my formula. So we'll put 42 in for angle A, 22 in for little a, and 116.59 in for angle C, and looking for little c. So how am I going to solve? Cross multiply, and then divide, right? Put that whole thing into my calculator. Now, there are some of you that if there is a faster, easier way to do something, you always want to know what it is. There are others of you that you're like, oh, please just give me one formula and let me work every single problem the exact same way. I'm good with that. I understand that. If you'll notice today, we have taken one formula and we've worked every single one of these the exact same way. But remember that when we were working over here, solving for angle B, remember it was a whole lot faster and easier? Like I didn't have to do the whole cross, multiply, and divide. All I had to do was just multiply by 12 and I had my answer, right? Whereas back over here when I'm trying to solve for C, I had to go back to that cross, multiply, and divide again. I had to do that extra step. Why is that? What's the difference between those two things? Why did I get to take the shortcut?
The variables in the denominator.
Right, the variable that I was looking for was in the denominator. I'm sorry, the variable I was looking for was in the numerator is why I got to take the shortcut. I had to do it the longer way when the variable was in the denominator. Remember that we said that this formula can be written in two different ways? If I wanted to, when I'm solving over here, I could have written my formula in that way. So now I've got 22 over the sine of 42 is equal to C over the sine of the 116. So if I want to solve, I don't have to cross multiply and divide. All I have to do is just multiply both sides by this sine 116.59 and I've got my variable alone, right? So just a suggestion, you're welcome to do this any way that you want to, but here's what I do. If I am solving for a side, then I write my formula with the sides on top. If I'm solving for an angle, then I write my formula with the angles on top. I can write it either way, right? So that means that instead of half of the time me getting to take that shortcut, that means every time I get to take that shortcut. And if I'm solving for, 2 angles on 10 different problems on homework, I might save myself 10 or 20 steps. So entirely up to you, but anytime that there's something that might make our life a little bit simpler, I always like to show that to you. So just for what it's worth.
So on our test, would you technically...
All right. So we've seen what we've seen what one solution looks like. What does two solutions look like? Literally, how do I get two different answers for the same angle in a triangle? That just sounds crazy. Well, let's look at it. Let's say that in this problem that we were just doing, what if the angle that we had over here, 42 degrees, what if it had not been so large? What if it had been like 10? Okay, now I'm not going to go back and recalculate all the values. So of course, if this angle is 10, this would not be 21.41 and 158.59, right? We would have gotten different angles. So just for the sake of argument, not algebraically sound, just trying to give you an example, okay? When we went through and we checked these two angles, the reason that we had to punt the 158.59 was because it was too large to fit in the triangle with the angle that we had there, because it was, like 42 degrees or something like that, okay? So if it had been 10 degrees, not only does 21.41 fit with room for a third angle, 158.59 would also be a possibility with room for another angle. That is what two solutions look like. When the two possibilities that I get both will work in my triangle. All right, so then how am I supposed to write the solution for that? Literally, I draw a line down the page and I say, here's one possible solution for this, and here's the second possible solution for this. And so I would go through and say angle B could be 21.41 or it could be 158.59. Of course, that makes C different as well, right? Because when I subtract from 180, I'm going to get two different answers if one of my angles is different. And then when I go to find little c, over here I'm using the 148.59 for angle C, but over here I'm using the 11.41 for angle C. That's going to make little c be different in both cases as well. So that's what two completely different solutions look like. Okay, what does no solution look like then? Back when I got to my Jeopardy button, remember we had sine was equal to some number and we typed into our calculator inverse sine. We always call that the Jeopardy button. So we typed in inverse sine. If the number that I have here, when I type that into my calculator, if my calculator gives me an error message, that means that angle does not exist. And here's when that's going to happen. Anytime that number is larger than 1 or smaller than -1. Because if you think about it, sine goes up to 1 and down to -1 unless I change the amplitude, right? So if I'm talking about the normal sine value, I'm asking it here, where is sine equal to 1.23? And it's telling me nowhere. Sine only goes up to 1. That's not possible. So that's what no solution would look like. When I get to that point in the problem, if I get an error message, I might as well just quit right there. There is no solution to that triangle. There's no need to keep going. Okay? So that's our ambiguous case. All right, last thing that we want to look at for this section is on page 432. On 432, they call this area of an oblique triangle. I'm not really crazy about that title because this area formula doesn't work on every oblique triangle. It only works on a side angle side triangle. So we've been working with 3 different types of oblique triangles today that were not side angle side, and so this formula wouldn't do us any good. All right, side angle side by definition is when I know 2 sides and the angle in between them. So like down here, I know this side and I know this side and I know the angle that was in between them. That's a side angle side triangle. All right, so they tell me to find the area of a side angle side oblique triangle. I'm going to do 1/2 one side times the other side times the sine of the angle in between them. So in our case, we were working with side A and B and angle C. So that's going to be this first version of the formula right here. So I could come down and say, okay, A was 90, B was 52, and C was 102. And then I can type that straight into my calculator, and I'll have my area. And remember that area is always measured in units squared. So in this case, they gave me meters, but if they gave me inches or feet or yards or centimeters or whatever, it's just going to be a square unit. Now, here's an easy way to remember this formula. Notice that it's just 1/2 one side times the other side times the sine of the angle that's in between them. The angle in between them is going to have to be the letter that wasn't used, right? Because if this is A and this is B, their angle has to be opposite of them. It couldn't be right there beside it, in between it, kind of thing, right? So here's the nice thing. If this is AB, then this has to be the letter that wasn't used yet, C. If this is AC, then this has to be the letter that wasn't used yet, B. If this is BC, then this has to be the letter that wasn't used yet, A. So you're going to use all 3 letters in the formula. That makes it pretty easy to keep straight and remember.